So, hello everybody. Thanks for joining. Today we will have a session about the end-to-end pipeline on IoT data analysis from the device through MQTT to a NoSQL database, and then we do some analytics using ApacheSpark. So we have a chat window here. So in case you have questions, please feel free to ask. I will have a look from time to time to see whether you have any questions, and I will be happy to answer them. Okay. So the first thing I want to show you is how to get started. So the very first thing to do is you get a free cloud account from the IBM Cloud. You can obtain one by typing ibm.biz/join IBM Cloud. So let me stop this one. And of course, I have a login now, but if you open that URL, you will be asked to provide your email address and a couple of more details. And the thing is, at the moment, it is a trial. You get 30 days of full access. Oh, 1 second, let me get rid of the mobile. So you get 30 days of full access, and after 30 days, it asks you for a credit card, but you don't have to pay anything unless you consume more, as we have in the free tier. So there is a free tier for each and every service, but this will change in a couple of weeks, and then you don't need even a credit card, and you have a completely free tier, and we call this model freemium. So stay tuned with that. This is basically the IBM Cloud dashboard. So it is a platform as a service cloud. You have also the possibility of run Docker images or virtual machines, or even a serverless computing model, which is called OpenWhisk, which is some sort of similar to the Microsoft Function or to Amazon Lambda. But the IBM one is based on open source. So OpenWhisk is written in Scala and it has an open source license, so you are not bound to the IBM Cloud. In addition to applications, you have also services. So everything, as it is a platform as a service cloud, comes as a service. That means if you need a database, you just click, and then a database is being provisioned for you. Let me just walk you through the catalog, and there you will actually see the abundance of services which are in there. And as I said, each and every service has a free tier. So you can see here, you can get bare metal servers, you can get virtual servers like infrastructure cloud, even VMware you can use. But you get also Docker images, Cloud Foundry applications, and as I mentioned, OpenWhisk, serverless computing models. Then let's have a brief look into the analytics section here. So you get an Apache Spark service and Big Insights, which is a Hadoop service, Elasticsearch, MySQL, MongoDB, Apache CouchDB, which we will use today, PostgreSQL, RabbitMQ, Redis, RethinkDB, what else? A lot of databases, you see. Let me have a look. Yeah, we have connectors to Twitter and Facebook if you want to obtain that data. Yeah, you can have a look yourself. So there are some Watson services. So those are the cognitive computing service, mostly used for natural language processing. So for example, there are services like personality insights, where you send data to the service and it tells you the psychological profile of that person. And again, you can try all these services for free, and every service has documentation. So if you click on the service, you click on view docs, then you get three things. You get the documentation, you get sample code, and you get the demo. So it's really fast to get up and running here. And what we will cover today is the Watson IoT platform and some downstream analytics. So the Watson IoT platform is also serviced in the IBM Cloud. You see here Internet of Things, and there are multiple other services, but we will concentrate on the IoT platform. And the IoT platform basically is mainly MQTT message broker as a service distributed among a multiple of IBM's data centers worldwide, and we will take care of fault tolerance, load balancing, failover. So everything you need is to call the API, and in 3 lines of code you have a end-to-end guaranteed delivery model of messages without taking care of any server-side implementations. Okay, so I will have a look if there are any questions so far. Okay, no questions so far. So I will continue with a very, very cool thing which is called Node-RED. Node-RED.org. So Node-RED is a graphical data flow editor which is open source. So IBM implemented it and donated this Node-RED to the JavaScript Foundation. It runs on top of Node.js, and we will use this for the data ingestion workflow. The cool thing about Node-RED is that it's running in the cloud, in the IBM Cloud, but also in other clouds or on your laptop or even on your Raspberry Pi. So you can actually implement an end-to-end IoT solution with Node-RED with only minor coding. And if you have to code, you only need to code a bit in JavaScript. If you don't like JavaScript or visual coding, then you can of course use any of our APIs, which are supported in multiple programming languages like Java, JavaScript, Python, C++, or whatever you can imagine. So let's have a look how to obtain such a graphical environment. So if you are in Bluemix and you go to the dashboard, we actually only have to click on Create App, and then it will ask you multiple things. But you just choose Internet of Things Platform Starter. And what this will create is Node.js as a service. So you don't have to care about any containers or virtual servers or whatever. So Node.js comes from IBM. It is supported by IBM 24/7. On top of Node-RED, there is Node.js installed, and in addition to that, also 2 services. One is Apache CouchDB NoSQL service, and the other one is the IBM Watson IoT platform, which is in its core MQTT message broker as a service. So I have already started this. So once you basically provide a name here, this test name automatically will be used as the host name or endpoint of your application, and you can configure your own domains, but per default it's mybluemix.net, so you have to make sure that this name is unique. So if you use a name which is already used, you will get an error message, which is not a problem, but I will just show you what happens. So if I now click on create, then someone already used the name Node-RED RKIE. Please enter different name. So that will happen. So just use any other and it will work. Okay. So after you have clicked on create, and will take 2 to 3 minutes, then it will be up and running and basically look like this. No, sorry, look like this one. So you click on the red button, and then the Node-RED flow editor opens. And the cool thing is, it, as I already said, it looks exactly the same on a Raspberry Pi or any other compatible device like Intel Edison or Arduino or whatever you can imagine. So everything which is able to run Node can run Node.js, and that means you actually can implement your data IoT data flow using Node-RED, but as I said already, using any programming language. So let's have a look at this flow. So this is now a simulator which is running on a IoT device. Of course, in this case, it runs in the IBM Cloud, but you can also run it on a Raspberry Pi. Since I don't have a Raspberry Pi here, I will just use this Node-RED and simulate a flow. So just imagine this flow now will run on a Raspberry Pi, and those three gray boxes are GPIO sensors on the Raspberry Pi, which are measuring some sensor data. So this is a hypothetical washing machine, and we are simulating fluid data, which, for example, emits data about hardness, temperature, and flow rate and fluid level of water, and data on current like frequency and voltage, and data on the motor, the speed of the motor, which is 1200. And then we add some functions that's just for simulation purposes, and add some random noise to it, because we can then use this data for anomaly detection. And then the only thing to push this to the cloud is using that connector here, and that connector basically transforms these messages into MQTT messages. And what you can do, for example, you can select quality of service, and if you select quality of service equals to 2, then you have exactly once guaranteed delivery end-to-end. Okay, so let's have a look if there are any questions. There is one question. Great. Thank you. Okay, yeah, I'm in my car because I'm on the road, but I'm in Switzerland, so this is not a problem. We have a 4G network here in Switzerland, which is quite fast. So in order to generate data now, let me connect these two nodes, okay? And that will generate messages. Or let's stop. Let's just deploy like this and activate this debug. So what now happens is, you see on the right hand side, you see messages generated, and those messages are basically JSON messages. And as you can see, those are nested. So I have a D property, and the D object contains data. And as you can maybe see as well, is that the schema of each message is different. And that's quite interesting, because later we will see how to cope with that schema differences. Okay, so now we have a test data generator simulating a Raspberry Pi deployed somewhere on this planet, sending data to the cloud. But actually it's not sending data to the cloud. The thing what is missing here is that connection here. So we connect these two nodes together, and we redeploy. And now what happens is, we see data flowing, but this is because I have a second flow, and this second flow is basically a flow which is meant to run in the cloud. Okay, so flow 2 is meant to run on an IoT device, but since I don't have one with me now, I'm using the flow number 2 to simulate an IoT device like a Raspberry Pi or anything else. And flow number 4 is a flow which is meant to run in the cloud, and at the moment it does nothing else than subscribing to the data. So I'm subscribing to everything which is going on that MQTT broker. Of course, I can filter by device type, or by device ID, or by event type. So that means actually, if I have, let's say, 1,000 washing machines, and I'm only interested in water temperature events, or let's say in current events, I want to detect anomalies on current. So in case I have 250 volts instead of 230, I want to raise an alert. I can subscribe only to current events, for example. But I'm subscribing to everything here. What I do is, I'm using a little function in order to get rid of the D nesting. I'm just wondering why I'm still seeing. Let me check one thing. I think I have another flow somewhere. Yeah, you see, that flow basically is crap. I will delete this. So I shouldn't see any data. Okay, now it's better. So let's go back to flow number 4 and activate this debug function. And now you can see we got rid of the nesting, so the D object is gone. And basically the idea is I can provide JavaScript functions and hook them up in the stream. And this notation here is called OGNL. I think it's called Object Graph Object Graph Notation Language, I think. And that's basically a way to access properties in a nested JSON tree or any other tree. HTML will work as well. And just to express which elements you want to access. And I'm accessing here the nested D object and copy the nested D object to the payload property. And that basically gets rid of the nesting. And I have a relational format now, which is a bit more handy. Okay, so okay, still works. So double check if there are any questions. Okay, no questions so far. Okay, let's continue. So now the thing is, I want to store this data coming from the IoT device very easily, and I will store it to a NoSQL database. So that's just the date, 6th of February 17, and that's the name. And let's call it washing. I say okay. So, and what I do now is I connect those, and as I deploy, and from now on, all the data gets streamed into Apache CouchDB database. And the Apache CouchDB database comes as a service in IBM Cloud, which is called Cloud. But that's not so important. The important thing is that Apache CouchDB, by design, is horizontally scalable, and it is dynamically horizontally scalable. That means if you need double amount of storage, you just add a double amount of storage nodes to it. If you need more computation, you need more computation nodes to it. And this is transparent for you. And as this Apache CouchDB comes as a service, it's transparent for you as well. So you basically only pay per GB and per month, which is around $1, I think. But you get, I think, 1 or 10 or 20 GB for free anyway. So that's a lot of data, so you don't have to worry about this. So we are streaming that data now into this Apache CouchDB as a service. And let me just walk you through how to get to this one. So this is again the IBM Cloud dashboard. And I can see now here the application. And this application has different properties, and one property is connections. So what I do now is I click on connections. Oh, I'm already there. And I have two services here bound to this application. One is the Internet of Things platform, which is, as I already mentioned, the MQTT message broker, and I have this Apache CouchDB service. If I click on View Credentials, just for your information, I obtain the credentials to connect to it externally. So if you want to connect to the IBM Watson IoT message broker, here you get all the MQTT credentials to connect to it from any MQTT capable device. By the way, if you don't have an MQTT capable device, you can also use HTTPS or HTTP. So you can send basically IoT data from any device on this planet to this broker. And the same holds for Apache CouchDB, which gives you back here the URL endpoint, username, password. And then if you want to see the admin interface, you just click on the service, and after that you will see a launch button, and then you get the UI. So I've already opened those. So this is the Apache CouchDB one. And now let's have a look at all the databases. So if you remember, I've just provided washing 6217 as a name, and this is lazy initialization. This will be created on the fly. As you can see here, I have washing 6217, 257 documents in it. All documents are stored as JSON documents, so let's have a look at one. And you see here the same data as we saw in Node-RED is stored in that. And again, you don't have to worry about storage. Once you have this pipeline up and running, you can store as much data as you need and want. And I will double check later whether 1, 10 or 20 GB are for free. But it's really enough, because it's only a very low amount of data per message. So this is the pipeline from the IoT device, like a Raspberry Pi, through the MQTT message broker. Let me show you the UI of the message broker. That's the UI of the IBM Watson IoT platform. So while data flows around, you can here manage devices. So there is no way of sending data to the MQTT broker without prior authentication. So what you can do here is you can add device types and devices, and all data is encrypted using TLS, and also access is restricted to those devices who have a proper API key. I want to show you just one interesting thing here, which is called rules. And rules is quite a cool thing, because if you know, without managing any server-side components on your own, if you want to just monitor your data, for example, if a temperature value is higher than a certain threshold or whatever, in this case, if the voltage is higher than 250, then create a message or an action, sorry. And currently there are multiple things supported, and there are a lot more to come. You can, for example, send an email to anybody. You can run a IFTTT if this then else. Maybe you know this, IFTTT, otherwise you have to Google for it. It's also some sort of a IoT integration platform. You can create a downstream flow to Node-RED, or you can call any web service in the world, okay? So that makes it really fast and easy to trigger an action based on any rule. And more interesting things are coming to this, because currently there are only thresholds, but we will add some advanced machine learning stuff here. So you can, for example, create an automatic anomaly detector rule, which raises alerts when there is some anomal data going on, okay? Another very interesting thing here in this rules section is that you not only can run rules in the cloud, you can also create an edge rule, which means you can configure a rule which is running on the IoT device. And this is for a couple of reasons. One is latency. If the rule runs on the edge device, you are omitting the network latency from the device to the cloud and back. That's one interesting thing. And the other thing is you can also save a lot of data transfer, because the rule actually is being computed and triggered on the device itself. But you can manage it here in the cloud. And either you purchase IoT gateway, which already supports this. I think the first one is coming from Cisco, or, which is even cooler, you can download Edge Agent. The Edge Agent is nothing else than a Java jar file, which is backed by the open source project called ApacheSpark. And you just put it on the IoT device. For example, you put it on a Raspberry Pi and install it and activate it, and from that time on you can manage your Raspberry Pi in that user interface automatically, seamlessly, and everything you see here in the user interface is also available on a REST API. Okay, so let's double check if there are any questions. Okay. Yeah, please ping me if you have any questions. I'm happy to answer them. So let's continue. So I'm now streaming still data into this database. I will now stop this. And let's also stop the data generation on the IoT device. So now let's have a look how to analyze this data. So now I have to remember the database name which I have used, which is washing6217. And now it comes to another interesting part. So we have a data science workbench in the cloud. And this data science workbench is based on multiple open source technologies. The core or the engine is ApacheSpark. So you get the ApacheSpark cluster as a service, and 2 workers are for free. So 2 workers corresponds to 2 CPU hyperthreads. And the cool thing is, if you have 2, you can test out parallelism. Okay, that's already a good start, and you get 5 GB of object storage for free in addition. So object storage in the IBM Cloud is backed by OpenStack Swift. So everything is open in the IBM Cloud, and the object storage is backed on OpenStack Swift, which is also a cool thing because you can use all the open source tooling for managing it. So let's have a look. And and the other thing is on its core it's ApacheSpark, and on the UI there are multiple things, but on the UI there is a open source tool called Jupyter. Maybe you've heard about Jupyter, which is basically a notebook. So that idea came from, I think, from Mathematica. Mathematica is a mathematics software package running on your machine. It's pretty old. And the idea was you can mix documentation, source code, and visualizations, and the same thing we will do here. So we will just start this. So now in the background, the ApacheSpark service is started. This is backed by some Docker images, so for the first time it will take a minute that your private ApacheSpark cluster gets up and running. So now this is the case. So let's copy this code from here to there. I will just copy this from here to there. So what we do now is we create a virtual table. So we will connect to the Apache CouchDB service. So let's do that now. So we run this cell here, and that basically creates a connection to the Apache CouchDB service. The cool thing is, since Apache Spark 2.0 smart data sources are supported, that means by accessing that table in the NoSQL database, we don't pull all the data to our cluster. We create only a pointer to it, and then if you issue statements against that pointer, then only data is read. And I don't want to get too much into detail, but the thing is, if you filter data, that doesn't mean that all the data gets pulled to your Apache Spark cluster, but only Apache CouchDB is told which data to return, and basically only that data is returned. That's a cool thing that works for MongoDB, for CouchDB, and for any SQL database. Okay, and also, if you're familiar with that, there's a file format which is called ApacheSpark, and also for Parquet this is supported, so you will save a lot of processing. So now you will register this so-called data frame. So what we get, this pointer which I told you is a so-called data frame object, and that we can register as a virtual table, and then we can basically issue SQL statements against this table. So let's actually say select star from this table and see what happens. So as you can see here, we have obtained all the data which resides in Apache CouchDB. But imagine there is 1 petabyte of data in Apache CouchDB. We still would be able to run this query like this, because it shows only the first 20 rows. And in case you are creating complex SQL statements, as much as processing possible is pushed down to the NoSQL database. So it's a very powerful pipeline. So let me double check if you have any questions so far. Okay. no questions, but still people are watching, so that's a good sign. So as I said now before, in NoSQL we have, in Node-RED we have seen that we are mixing data from different sensors. So that means every sensor has some sort of unique schema, and that gets all stored into a single table. This is something which you can't do in SQL so easily. So what you can see here, for those rows where basically data is missing, you get a null value here. And of course what you can do here is you can say select temp, or let's say voltage from this where voltage is not null. Let's see where that works. Okay, so you see you get only the voltage column, so you are omitting all the other sensor records which don't contain voltage. And now you can start with that statistical stuff. You can say select the maximum voltage, and you see here's a 259, which is a pretty high value. So let's have a look how many of those values you have. So let's say select count of voltage. So we have 156, and if we say where voltage is bigger than 250, which is quite high for a washing machine, I assume. You see there are 3 values, and that's a very, very, very simple way of obtaining a threshold. More sophisticated measures would, for example, be a moving z-score. One thing I forgot to mention, if you are interested in getting more details about all that stuff, we have 2 courses. I will put that links into the YouTube here recording, no worries. So we have 2 courses on Coursera. Pretty proud of that. So the first course teaches you how to connect the IoT device to the platform and do some basic data processing in Node-RED and in Python. That's a course taught by a colleague of mine, which is called Brian Innes, and the other one is the one I have been creating with my colleagues, and this is the first course of a 3-course data science specialization in Coursera. And the first is on exploring and visualizing IoT data, and that basically teaches you everything I've shown you until now, plus calculating those advanced statistical measures, and also some sort of visualization using a matplotlib. So it's a quite interesting course. It's 4 weeks, so I can really recommend it. Yeah, that's all what I wanted to say for that. So I will double check if there are any questions, and if not, then I want to play a little IoT game with you. Is there a tutorial how to run edge rules locally on Raspberry Pi? There is one. I will provide this to you afterwards, or I will post that. I will post it to the recording and to the meetup page. So stay tuned for that. But I have to search for it. Okay, so no more questions at the moment. So now I want to play a little game with you, and the game is as follows. So as I told you, the IBM Watson IoT platform backed by a MQTT message broker basically allows devices capable of sending MQTT messages to connect to it. And we have a little demo application which runs on your smartphone, and it's only a web page, so no need for installing any app, and it uses 2 JavaScript libraries. One, of course, is the MQTT library, which connects to the IBM Watson IoT platform, and the other library is a library which allows you to read the accelerometer sensor values of your smartphone. And that's pretty cool, because then you can move or shake your device and all the data gets streamed into the cloud in real time. And with that pipeline we have created just now, of course, we can easily create a little application measuring the energy you create while shaking. And that's something I want to just play with you. So for those of you who are interested, please open following URL. It's ibm.biz boom boom shake shake. And please wait before you insert anything. I have to tell you what you have to insert, but I will just make this a bit more easy for you. So I will paste this link to Word so that you can read it better. But it's very simple. ibm.biz slash boom boom shake shake. I will put it back later. Let me put it in the chat box. So now you have it. What happened here? It seems that I'm not allowed to send links or what? Yeah, strange. Okay, well, for whatever reason, it's ibm.biz slash boom boom shake shake. Anyway, so let's open that link for you. Of course, I opened it now on my laptop, so it won't work. But what you have to do is you have to insert a unique ID only containing lowercase characters, eight lowercase characters. That is your user ID, which we will use later to obtain the winner. And then the second thing, let me just do this. 1, 2, 3, 4, 5, 6, 7, 8. Okay. The second is a password. Also 8 lowercase characters. So let me also put ASDFGHJK. So what now happens is that you see here it's connected. So that's the JavaScript MQTT library connecting to the MQTT message broker in the cloud. And I'm publishing messages. And as I'm on a laptop, I don't have any accelerometer or gyroscope values here. So that's pretty boring. But what will happen is I will see, oh, you are also already playing. That's cool. So folks already started to play. And what this app does, it automatically registers the devices to the IBM Watson IoT platform. So everyone who is playing here is displayed here, and you can also click on that value, and that all is already enough to create rules. So for example, you can create rules if somebody shakes really hard and the data is really high, then just send an email or trigger any other action. So that's the data you see here flowing in real time. And let's go back to Node-RED and deactivate this one. So you see here the data is getting in, and I assume this user RITWIKJO is also running this on the browser, because I don't see any values here. But here the other ones are sending from a real mobile device, and I think also shaking a bit. So that's a relatively low value, but it's more than just lying on a table. So what we do now is we stream this data again to this database. And now the game can start. So I just double checking if there are any questions. No questions. Okay, now we can start the game. That means if I now click on deploy, the data gets streamed into the database, and we will just run for, let's say, 30 seconds. Let me check. Or maybe 20 is enough. Let me start the timer. Where is the timer? I have to search my timer. Stopwatch. Okay. I hit deploy, and once I hit deploy, please just shake your device as hard as you can. And remember, you have to shake it in 3 dimensions, because there are 3 sensors being recorded. So if you just shake up and down, it won't work. So you have to find some interesting and hard shake pattern in all 3 dimensions. Okay, are you ready? 20 seconds starting now. Boom, boom, shake, shake, boom, boom, shake, shake, boom, boom, shake, shake, boom, boom, shake, shake, boom, boom. 10 seconds to go. Boom, 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 shake, shake, boom, boom, shake, shake, boom, 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 shake, shake, boom, 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 shake, shake. So, okay. Now I will remove this connection. So I will still see data flowing in, but I'm not recording it anymore. Okay. So that actually means I can now access the data using ApacheSpark, which I will do now here. So let's go back and copy paste this table name, and oh, that was crap. Double. So I'm registered. So I'm reading now boom 6217 as a data frame, but now I register this data frame as a temporary view called shake shake so that I can issue queries against that. And what I do is I will create a SQL statement. So let me briefly explain to you that SQL statement, okay? Or let me first show you how this data looks like. Okay, it's cloud and data dot print schema. So let's do it. So you can see here it's ID and revision that comes from Apache CouchDB because there's some versioning going on in those JSON documents, so we can ignore that. So what we are interested in is AX, AY, AZ. Then ID, that's your device ID you have provided, and we are basically ignoring OA, OB, and OG, which is the gyroscope. So we are ignoring the gyroscope values. And let's issue that SQL statement here. So I will walk you through that SQL statement briefly. So in order to obtain the overall energy which you have created, we are just summing up the values, and that basically works because the overall energy, if you consider a graph, the integral of this graph will basically resemble the overall energy. So the surface below and above the line is the energy, and in order to obtain that you can either integrate the function, but since we are sampling 10 times per second, we can also sum up those values. So we are sampling everybody 10 times per second, so it's a fair distribution. And we are taking the absolute value because there are of course also negative accelerations, and we will turn those into positive. Then we sum up all those values on each axis, and then we sum up all the axes. And finally, we will store this as an energy value. Then we will also use ID to obtain the winner. And then the interesting thing is we group by ID. So we sum up all the values for each participant. And then finally we order by energy descending. That means the highest energy value will be on the top row. So let's run this. So, and now we have seen Ruby player boom boom shake shake is winning by far. So congratulations. And I think that was myself, and you just didn't use your smartphone, or maybe you don't have an accelerometer in your smartphone. That's also possible. Okay, so that basically concludes my presentation, and now we'll have a look at the questions. Okay, so if you joined late, this is not a problem. I have recorded this session and I will put it to my YouTube channel, or actually it's automatically put to my YouTube channel. No, actually, I think Guido, no, it's Guido. most likely. So this is now completely based on YouTube streaming, so you don't have to be logged in nowhere. You just open the link and it starts streaming, and it automatically gets stored in the IBM Cloud. Okay, so I'm just waiting for a couple of other minutes to see whether you have any questions, and if not, then I will close the session. Otherwise, I will um, um, oh, your phone almost fell off your hand. Okay, so I'm not taking any responsibilities. I should have said this before. Okay, if you have any other questions or so, please let me know by either commenting it here or on the YouTube recording or on the meetup. I'm happy to record and provide any other sort of training. So I'm working as a data scientist in the IBM Watson IoT team. I have quite a lot of client experience and also experience in all the platforms. I'm covering Europe, Middle East, and India as a territory. So please let me know if you have any questions, or so I can, for example, create a session on deep learning or TensorFlow or Spark itself or Raspberry Pi, whatever you like. Just let me know, and then I will create the sessions. I'm also starting a YouTube channel, by the way. So I want to create some more formal videos and which maybe look a bit more professional to give you some more information. Okay, I will just provide my email address here. So you can just ping me in my email address and then we can have a chat about this. Okay, I will wait just for 1 more minute. Otherwise, just feel free to ping me on the meetup or on YouTube. I have also Twitter ID if you like to connect to me on Twitter. Okay, TensorFlow. That's a good thing. I think it's especially interesting for edge analytics. So you can run it in the cloud, of course, but I think real strength is that you can run it on mobile devices and for example, you can create the models in the cloud using the data from all the devices and then push the model to the IoT device and have it scored in real time. Yeah, that's a good idea. So I will prepare something on TensorFlow for you. I have something ready on Fiano and Lasagne. I think I can also present this, and of course I can port it to TensorFlow as well. It's an anomaly detector using LSTM, so it's a long short-term memory network, and that is particularly useful for anomaly detection. So it's a very powerful technique, and I get really good results. So I can present the Fiano Lasagne one first, and then I will port that. Yeah, Guido, I agree that it's far better than last time. So I really think I found the tool now. Just thinking of getting an audio back channel that you guys can talk to me directly. So if you have any ideas, let me know. Otherwise, I will come up with some idea there. Okay, I think I can close this session. So thank you very much for attending. And I will announce the other ones on the meetup page. And also next time, if you subscribe to my YouTube channel, the next streaming session I will announce also using the tool in YouTube. So you will get notified as well if you like. So thank you very much and have a nice afternoon, evening, night, wherever you are. Thanks so much for joining. All the best and see you next time.